Today I want to talk about similar and congruent figures. So congruent figures have the exact same shape and size. Translations, rotations, and reflections will all produce congruent figures. The size does not change. And then the symbol for congruent is the equal sign with a little squiggly line on top of it. That means is congruent to. Similar figures have the same shape but a different size. So dilations are the ones that produce similar figures. The figures enlarge or they reduce. But everything, all the side lengths are still in proportion. And then the symbol for similar to is just one squiggly line. Now the angles of similar figures, this is a misconception here. Angles are still congruent. This is what helps maintain the same shape. So if you look at this figure, all right, this side goes from 5 to 15. Think about that. What can you do to go from 5 to 15? You're getting 3 times larger. It's the same from 4 to 12. You're getting 3 times larger, but look at the angles. This angle here is 37 degrees. Look at the matching angle right here. That one is 37 degrees. The angles do not get larger. Right? Angles stay the same. That's what helps maintain the same exact shape. Just because the side lengths get 3 times bigger does not mean that the angles get 3 times bigger. Otherwise, it wouldn't make a 180-degree triangle. So now the side lengths of similar figures, the corresponding side lengths are proportional. This also helps maintain the same shape, but it's what makes the size different. Everything is in proportion. So if we look, give me a second here, we went from 10 to 5. That one got reduced by half. We went from 6 to 3. That also got reduced by half. All right? If one side reduces by half, then all the sides need to reduce by half. Otherwise, it's no longer proportional. So we are going to spend a little bit of time finding missing side lengths. And I know you did this last year. You set up a proportion. So you looked at one original side length and another original side length, made that a fraction, and you put it equal to the new side length, the matching side length, over another matching side length. Now, just a side note, there are lots of different ways that you could set up this proportion. This is probably the best known way. All right, but you could put original over new is equal to original over new. It's fine. You just need to make sure that everything matches up. Like I said, we are going to spend more time in class doing that. That's one way that you can find a missing length. What I think is the easiest is look for equivalent fractions. All right, that's pretty much what I just did. Going from 10 to 5, you're reducing it by 2. We don't need to set up a proportion for that. Find little shortcuts. And then the other one is to use cross multiplication. And I know you guys did that last year as well. So here we've got an example where they're finding the missing length, and they've set up a proportion. All right, so I want you to look and see what they did. They took 3/8, the way that they got that, 3 over 8 is equal to what number, question mark, over 16. That's where they came up with this right there. Then they used your cross multiplication. 8 times x is 8x. It's equal to 3 times 16, which is 48. They solved for x, divide by 8 on both sides, and they got 6. But let me show you something. Look for, oops, hold on one second. Oh, man. Sorry about that. Look for easy relationships. Look at this. This is going from 8 to 16. Think about it. How do you go from 8 to 16? Multiply by 2. So what do you think you need to do to that 3? That's right. Multiply by 2, and you still get the x equals 6 inches. I think that's the easiest way. It's a lot less time consuming. Look for easy relationships first. Alright, then set up proportion, do cross multiplication. Again, we'll be working on this tomorrow. See you then.